In this video lecture, we're going to talk about the design of a list class. And this is our first container class. And a container is designed to store collections of objects. It contains other objects. And the analogy that I like to use is that of an egg carton. Okay? So remember that we had, from the previous lecture, we had an integer that we were storing in a node, and then we were stringing the node together into some sort of a list. So here, for example, you've got 5. And then we had the nodes that we were stringing together into these linked lists. But we were just doing this in main. And, you know, really what we need is we need a container now to wrap all of this together. So let's say, for example, in these nodes I have 5 and 10, and really what the container is going to do is the container is going to wrap around this linked list. So I like to say that this object is the egg, the node is the egg cup, and then the container itself is analogous to the carton. And it's really important to keep these three things in mind, that you have the object you're storing, you have the node you're storing it in, and of course that lets you navigate between nodes. And then, as we're going to see in this lecture, we're going to build a list class or a container class that will provide a public interface to the manipulation of the list itself, independent of what we're storing in the objects. And in fact, that insight that these manipulations of the list can be independent of the objects we store in the list leads us to something we talk about later called templates. And so we'll get to templates in the second semester, and that lets us store any objects in our list. And so and right now what we're doing is we're going to create a list of integers. So our list is going to be object specific. Templates let us write containers that are not specific to any object. And you've already experienced the vector class, and as you know, you can create a vector of integer objects. And so a template class is how they implemented the vector so that you could use it for any class. But as we're going through this, keep this egg carton analogy in mind, and always remember that there's a distinction between the object, the node that is storing the object, and then the overall container that's organizing those nodes in some fashion. Right now we're going to organize these in a linear fashion, but as we go along, you'll see that there are other ways that we can organize the egg cups of a carton, just like, sometimes you can buy a 6 egg carton or a 12 egg carton or an 18 egg. So there are various ways that we can organize these nodes and these egg cups. So the name of my class, and what I'm doing here is I'm defining this, and the name of my class is just going to be a list of ints. And we're going to use the node. So this is going to be, of course, I have an integer here, I have a node here, and then the collection of nodes will be a list of ints. And it's going to look exactly like this. And I'll get around to defining my public interface in just a minute. But my private data member, I need something to hold on to this linked list of nodes. And this is what I was talking about with the head pointer and the kite string. That is going to be my private data member. And the way this is going to look, I should have drawn my diagram a little bit better, but if I extend this out, I'm going to have this pointer called head pointer, and it is going to point to all of the elements of this linked list. And as long as I maintain the integrity of this head pointer, then I'll be able to access the elements of my list. Now, container classes with a head pointer are a departure from all the classes that we've discussed thus far. I am not going to give other programmers access to this head pointer. And in fact, I'm violating my simple algorithm for the design of classes, because if you follow that, then I'm going to create a set and get method for head pointer. Well, I'm not going to do that. And in fact, these container classes do exactly the opposite. They prevent programmers from directly accessing the internal representation of this list. Now let's just go back and review and take a look at, that example that we had before. So here is our node class, and hopefully you've got that coded up. And remember the example, we had a portion where we constructed a linked list. And so what I'm doing here is my head pointer, the private data member of my list class called head pointer, is going to play the role of this node pointer that always points to the first element of the list, and then that's how I'm going to be able to access and perform operations on the elements of the list. Then we also talked about traversal, and we'll see where traversal comes up in the implementation of our class. And then we had destruction. We had destruction where we traverse the list and delete each node. Well, this was all just code in the main function, right? I mean, I just had this in a main function. And what we're going to do is we're going to take code or code that's inspired by this example, and we're actually going to put it into methods. We're going to encapsulate these operations in methods of my list events class. The first thing I'm going to need is a default constructor. And as you will see, all it's going to do is assign this head pointer to null, because when I first create a list of integers, it has no contents. So head pointer should point to null. Then we're going to look at a method that reads integers from a file. So I'm going to let someone pass in a file name of integers, containing integers. It will read the integers from the file, and it will create a linked list. And just for convenience, and to also illustrate another use of overloaded methods, I'm going to create a read method that just takes an iStream as an argument. And what I'm going to do is this version of read is going to open a file stream based on the file name, and then it will call this read method by passing in the open input file stream. This just gives me a little more flexibility in where I can read integers from. I'm going to implement a print method. This will simply print the elements of the list to the console. Although I'm going to pass this in as an output stream, so people will decide if they want to, by default, come from the console, go to the console output, or if we wanted to print to a file, then they could pass in an output file stream and it would go to that file. I am going to implement a clear method. This will let a programmer remove all of the elements of the list, and then I'm also going to need to implement a default constructor. I'm also going to implement a destructor. And a destructor in this instance is required because we're using pointers and we're using dynamically allocated nodes. So let's say that I leave the scope of some block in which I've declared this list, and it still has the contents 5 and 10. As you know, the destructor automatically executes when we leave the scope in which we've declared this list, and so our destructor is going to traverse this list and delete each individual node just like we did in the example. And in fact, this is the same operation that the clear method performs, so our destructor is going to call clear, and you'll see that in the implementation. This just gives someone using my list the ability of clearing it themselves. So this is the design, a simple design. There are some other methods we could implement here, and we'll talk about those later. But this is the simple design of a list class, our first container, using a singly linked list of nodes of integers.